Good evening. My name is Tina Fawcett. This is a presentation about work done by myself and my colleague Marina Tapuzzi. We work at CREDS, which is a UK multi-university research centre into energy demand solutions, and our institutional basis is at the University of Oxford. And this paper that contributes to the special issue is about the role of carbon metrics in deep retrofit of buildings. And Marina and I both come more from an energy policy expertise than being particularly focused on metrics. So we were trying to understand really what the importance of metrics is in relation to all the other things that influence how buildings get renovated and how we're going to need to accelerate that due to the climate emergency. So this was our central question really, is are the metrics we've got at the moment, are they fit for purpose in the climate emergency? Can they help us do, make further and faster changes to the building stock to reduce the energy used and to replace the energy that is used with zero carbon energy? So why does this question matter? Well, I think for this audience, I can be very brief on this. We've already heard statistics about the importance of energy use and carbon emissions from the building sector. We're focusing on the residential sector, which is 27% of the EU's final energy in 2017. So this is the energy figures. Clearly, if we're going to meet zero or net zero carbon goals, most buildings are going to need low energy and low carbon retrofit before 2050, because most of the buildings, particularly in Europe, in 2050 are the ones we've already built. We would hope new buildings are zero carbon, but unfortunately that's not actually true. So quite a lot of those will also have to have changes by 2050. So the metrics, or these quantitative systems of measurement, are critically linked to standards, targets and policies, the things that enable and enforce change. And as we know, metrics, we've already heard why metrics are very important at the project level and at the sector level, but Kran et al. Also say they influence the outcomes of scientific research, political decisions and investment by private parties. So they're really important at many different levels, and I guess I don't need to make that case more strongly here. So what was our research and what wasn't it? Well, what it wasn't was we weren't trying to find this hidden treasure of the perfect metric. And I think most specialists in metrics wouldn't say that there was one, but sometimes there is an idea around in debate that if we just got the right metric, then we could really get a move on, and it's bad metrics that are stopping us from making progress. And I don't think there's much evidence that that's too simple an analysis. So what we did was we looked at some literature. We tried to focus on key characteristics of retrofit metrics and how they were relevant in the climate emergency. And having done that analysis, we then looked at 2 case studies of residential retrofits where metrics are important. One is energy performance certificates that are used throughout Europe, typically A to G labelling on houses. And certainly in the UK and elsewhere, their use has been massively expanded. Well, is that okay or is it not? And we also looked briefly at Energiesprong, but I'm not going to talk about those cases particularly. I'll give you our more general thoughts. So to try and make some sense of this complex world of metrics, we decided we needed to simplify and focus on a few issues, because as many of you will know, there are hundreds and hundreds of different metrics out there, and trying to understand it all is, it's difficult. But if we focus on some key issues, that can get us a long way. So what we said the key issues were scope, as in which stages of a building life cycle are included and which uses of energy. And we've already heard the case of life cycle analysis and how important and complex that is. What the headline measurement of or calculation is, whether we're looking at energy or carbon. What the normalization factor is. So are you looking per square meter, per inhabitant, per building, per degree day? So that's important as to what the real meaning of the metric is and what it helps you do. And then the time scale and the point in time to which it's applied. And again, that links very strongly to arguments around embodied energy. So that was one set of simplifications or ways of trying to understand this field that we used. The other was to use this scale diagram that you can see, this triangle scale diagram. And this is, I suppose, making quite a simple point, really. And it's saying the higher level, the more aggregation you do in your metrics, in a way, the more general your metrics is. So at a global level, we're looking at 0 carbon by 2050, or whatever the case may be. That's the target. Whereas if you're looking at an individual building, you might be looking at a range of targets, including carbon and energy per square meter, how much energy you're going to use for heating, how many what sorts of renewable energy targets you've got. So you have a lot more data, a lot more metrics at play to get the result that you need. So those were the two key framings that we used in thinking. And now I'm just going to introduce you to some of our findings. So one key message that came across from the literature was that retrofit metrics actually embodied values and views about how retrofit should be undertaken. Metrics are not value-free. They might be independent, they might be measured, but how you frame them very much determines how you understand how a building's performing. And looking at primary energy or delivered energy or carbon only will all give you quite a different understanding, particularly comparing between buildings. So we need to recognize that. I've already stressed that unpacking this metric design and looking at the 4 separate elements I talked about can help inform better policy decisions, because it helps you understand the trade-offs that you're making. Metrics for different scales require different amounts of data, of course, and they're designed for different audiences, and that's quite important in how they're used as well. And I think a very clear message that came through is that combinations of metrics are key to delivering urgent change. So there isn't an ideal metric, and in fact, many building standards, for example, the Passive House Standard or other standards, embody more than one metric already. And energy metrics remain important. I think that was another thing that came through again from some of the literature and from some of our analysis. So if that's where we are with metrics at the moment, how do they need to change as we go into the climate emergency and we want to do a lot more retrofit to a lot more buildings? What does that mean for the metrics that we use? Well, what we're suggesting is that we'll probably need new metrics and new combinations of metrics, which will need to look at the whole life of the building. So taking these issues of embodied energy and whole life cycle more seriously, because those are not in most of the policy metrics that are used at the moment. We need to look at the time profile of retrofit. When's it happening? Is it happening now? Is it happening all at once? How are our metrics going to help us manage those different processes? A new one, we might be looking at the ability of a building to be flexible as to when energy is required, because as we know, the energy system is changing to rely on many more intermittent sources of renewable electricity, particularly, and we're probably going to be moving our heating and cooling to electricity. And so flexibility in timing is much more important in these non-fossil fuel-based systems. And finally, well, we also need to think about larger scale issues. I mean, single buildings fit into much bigger energy systems and city level systems. So metrics that just operate at the level of one building may not be right. And finally, of course, we need to look at people and how people interact with buildings determines performance a lot. It's not just a technical issue, as I think we would all know. And since everybody's going to have to be involved with this, we've also got to think about how metrics can be more widely understood, not just for specialists building 0 carbon buildings. So that's my presentation. That's where we got to. And I would just like to ask you some questions, is whether you agree that combinations of metrics are better than simple metrics, or are we in danger of overcomplicating things? Have you got any good examples of metrics really helping to accelerate action and deliver better results? And finally, what do you think about the suggested directions for the development of metrics? Do you think that's right? Have we missed something out? And so I look forward to your response. Thank you.